Um, Welcome, everyone. So my name is Tomasz Trzciński. I'm a CEO of Comixify. I'm also chief scientist at Tuplux and assistant professor at Warsaw University of Technology. And today I just want to share a few words about the app or technology that allows you to turn videos into comics. That's Comixify.ai and what it does. All right. So Comixify takes videos either from YouTube, Twitter, Vimeo, or your own videos and your own content, and using a very simple, seamless UI UX website that allows you to basically do just simple this: take a URL, paste it there, or take your data and paste it there, and generate a comic. So first thing that we do is we select the most relevant frames. These are the frames that describe the story behind the video. These are the ones that are representative and they actually are of high quality. They are aligned within the comic strip. This is one of the layouts that we selected. There are also ways of selecting a dynamic layout, which means that you can actually see some randomization in that. We transfer the style using our proprietary comic scan that is allowing you to transfer the style of the original images into comic. There are several filters, as they call it, available. We actually learn it from the data itself. So we are not drawing those. These are not simple filters that you can play with, although they may look similar. But we are actually learning them from the data. And then we add bubbles and input text into the bubbles. So that's as simple as it is. It's pretty straightforward, but there's some tech behind it, and that's what I want to tell you a little bit more about. So this is pretty much the overview of the whole process. We start with the keyframes extraction. So we select those frames that are representative, characteristic, and also good looking. This is done through video sampling, through some scoring of the frames, temporal segmentation within those scenes that you see in the video, and also the estimation of the quality. And then we do the style transfer after all. All right, so let's move into the first part, which is keyframe selection. So what frames are we looking for when it comes to comic or comic strip? We want the frames to be representative. So, having a sequence of frames that look more or less the same, and it doesn't tell the story, so we don't want those. We want ideally those that are actually, with the action. Pulp Fiction is a good way for, feeling the action of the movie. So that's one thing that we're looking at. The other thing is diversity. So they need to look differently. They also have, in the left you see Darth Maul is still the same scene. So that's not something that comic writer would do. We want to have a different, lookups on the faces and things that actually follow the story of the video sequence. And ideally, you want them to be of high quality, which means that they're not blurred, they're not, foggy. You actually see something pretty cool in terms of the quality of that. So this is the three main features that we're looking for in terms of comic strips, and that's what our algorithm is going to select, or that's what we train it to select. So video sampling first. We take the sequence, such as the one that you see in here, and we sample with 2 frames per second. That's it, no artificial intelligence here. There's a bunch of frames. That takes a bit. That's why when you're loading your video and when you're uploading it, it actually takes quite a bit of time to split it and put those frames one to the other. Then we get into interesting part. So this is the summary score. So we use a concept of video summarization as the way to select or to score the frames. And the main principle behind this is using reinforcement learning. And the end goal, the reward function, is taking 2 things into account: the diversity and the representativeness. And these are actually the unsupervised metrics that we can get out of our frames. So through diversity and representativeness, we're actually looking at how representative and diverse the frames are in some space of features that we extract those frames into. So we take the inputs, we extract the features from those. See you here, CNN, and then the space of features in the bottom of the page in deep summarization network. And then what we're doing is we're basically optimizing the whole system to select a subset of frames so that it actually optimizes the final reward function. And since there is a multiple combination of those, reinforcement learning is pretty useful for this sort of optimization problem. Then summary score is actually used in the next part. So the output of the reinforcement learning would be a sequence of frames that tell you the story. But inside there is a summary score, and this is something that we are using in the next step. So for each of the frames with the reinforcement learning algorithm that I described in the previous slide, we draw this temporal function of summary scores of each frames. This looks pretty similar to New York Stock Exchange graph, so it's not really useful to find the most and less relevant frames because there's a lot of bumps and ups and downs. So what we do is we apply temporal segmentation. So obviously within the frames there are some frames, some scenes that are more representative, some of those that are less representative. And this is the part when we take that into account. So we don't want just the frame, just a single one to be representative. We want the whole scene. And by scene, I mean like a cut of a video to be representative. This is the point of temporal segmentation. All right, so the summary score that you're getting out of this, instead of this kind of a New York Stock Exchange graph, it's kind of split into the parts. Then we take the average of the summary score within each given scene. And this is the output of the averaging within the frames. And then we order it. We sort them based on the decreasing summary score per scene. And this is the subset of frames that we got from this part of keyframe selection. So actually within the part of the scene, we take the frame with the highest score, but the scene that we selected was already the one with the highest average summary score. This is pretty much how we select the initial candidate keyframe set. Now that we know that those frames tell the story, there is the last feature or the last characteristics that we want to optimize the selection of the frames for, which is the quality. So for that, there are a bunch of models that we used in this presentation, and this is actually the presentation of our original idea that we submitted and published 5 months ago. Now we're playing a little bit more with other options, but the one that we submitted in the paper is based on the Neural Image Quality Assessment Network. This is the NIMA model. And it basically takes a bunch of images. This is a set of images that you can find on the internet. And then based on the quality, quality here means the popularity in the internet, it actually estimates if it's good looking or bad looking image. This is a very simple architecture. And baseline image classifier network can be any network. It can be ResNet, it can be ImageNet, it can be ResNet, it can be GoogleNet or anything else that comes to your mind. Then you have like fully connected layer and a softmax. And then you get a quality prediction on the output of this network if the image is good looking or bad looking. Now what the quality is, as a lot of photographers can say, is not only the popularity, there are other things. There is how sharp the image is, and there are other estimates of the quality that you can use here. This is all fine. Just we used the model that was trained on the data that we had, but you can optimize here for any other things that you would like to see in terms of quality. All right, so these are the frames that we get. This is the output of NIMA, so the scoring model that we have. And there's one more step before we actually get the final cut and the final set, which is coupling those in pairs. And within couples, we select the maximum score out of those two that follow each other. This is a trick or heuristic that actually allows us to still push those frames that are representative a little bit apart, so that we don't get like a sequence of high scores and then nothing at all, because that would not actually contribute to the story. And that can happen if you have a very good opening of scene and then the rest is of poor quality or is not representative enough. So this way we actually equalize the emphasis throughout the whole sequence of a video. And so these are our selected frames. We put the layout, the comic layout on those frames, and we move on to the style transfer. And this is the network that, or the solution that is based on generative adversarial network. So as in any other GAN, you would have a generator and you would have a discriminator. Those two networks are fighting with each other to optimize to find the final equilibrium of the loss function. In the loss function, we have adversarial loss, so the one that is coming from the discriminator, and the discriminator is looking at is it a cartoon or is it not a cartoon? That's kind of our way of looking at is it false or true, is it a real image or a false image. There is another loss that we're adding, which is content loss, and this is the loss related to style transfer. If you're a little bit familiar with a style transfer as an idea or as a concept, within the neural networks, there are certain layers that correspond more to the content and a little bit more to the style. Those that are typically deeper, so a little bit closer to the image, to the input, they are more related to the style. They are actually focusing more on the edges and curves and things like that. And this is where content is not used that much. It's more of a style. On the top level of the neural network, you see more analysis of the content, and this is where the content loss is taken into account. And what content loss is optimizing for is that you still see the output being a human, for example. It's a different style. That's the part where we're looking at the discriminator. It's a different style, it's a cartoon style, but there's still somebody that looks like a person. So content images that we input are the real images, like the ones from the movie scene. There is another trick that needs to be applied, which is blurring the edges of the images that are input into the discriminator. So we don't only input as a real cartoon images, that are the real images, but also the smooth ones. And that seems to be working pretty well. There are a few other implementation tricks that allow us to actually get the results that we're getting. And talking about the results, this is the input image that we can give to our comic scan. And this is the one that we will generate in the top right. The bottom ones are the baselines that we were comparing our system for. So as you see, our drawing is much more cartoon style. The previous work is a little bit more dull, and the colors are much more different than the original version. And what we actually wanted to achieve with comic is just keeping similar colors, but still adding this drawing kind of thick line characteristics of comics. So we launched the service in December 2019, or sorry, 18. And since then we got 150,000 visits on the website. We generated over 40,000 comics. We actually got returning users. Some people love comics so much that they're actually coming back and generating more comics, which is great for us. We have incorporated a company. We have trademark on Comixify. So if you use Comixify, we can sue you. We're not gonna, but still. We have added a couple of new cartoon styles. And there's Simpsons that you see here. I think 2 days ago, one of our co-founders actually sent me like I think South Park style kind of a cartoon. Well, there are other inspirations that we're drawing from the cartoons, but that's upcoming. So you should visit the website and see how it evolves. And we got quite a bit of worldwide media coverage from Engadget, from MIT Technology Review, and some other big media outlets. We were also named one of the most important AI trends by CB Insights report. And we basically looked into what brings people to Comixify. And there was a bunch of applications or a bunch of results that we discovered. This is a typical question at a startup pitch, like, okay, that's pretty cool. You guys can draw a cartoon, but what the hell are you going to do with this? So first of all, people use it to come up with some sort of a summary of their memories. So they very often upload videos of their weddings or some sort of a trips, and then they combine it into a comic. There are some people that are actually using this to find a snippet of a longer video content. So comic strip is something that summarizes very well a longer content, and this is especially important in all the media fast with a lot of content being generated, a lot of videos that are never being watched. Having some sort of a form of summary or getting the essence of the video is one of the potential application of Comixify that we observed that users are actually happy with. That's also for YouTubers or vloggers, those guys that actually have a lot of content and still they want to promote it somehow in different outlets, in different media. There is another application that obviously brings the attention of media industry, which is cartoonizing the whole video sequence. And in the top left corner, you see the input. In the bottom, in the top right and bottom left, you see two different outputs of our filters. And in the bottom right, you see how we can combine the segmentation of the humans out of the scene and just cartoonize part of this scene. And this is called rotoscoping in animation and in video industry. That's typically done by humans with a lot of drawing, a lot of cutting out and in people, and then just animating part of this. So we can do it pretty easily with the software that we have. All right, let me just. Okay. And last but not least, we were contacted by kids, therapists that treat kids, they offer therapy for kids with autism, and apparently comics and comic strips are very helpful in the therapy of kids with autism spectrum disorder. What they typically do is they print the comic out of the website, they take the bubbles out, and they let the kids put the bubbles or text into the bubbles. Apparently kids with ASD, the autism spectrum disorder, they're finding it very hard to feel as if they were other people, and this kind of gives them a snapshot of what is the situation, the social situation that they're dealing with, and Comixify allows them to actually generate a lot of different content with a lot of challenges on the social side, and that's what we're looking for as well in terms of the final application of the technology itself. So it allows you to actually generalize to a much higher number of or much bigger number of scenes treating this therapy. All right, so last but not least, we got accepted as a company to Synthetic Hub of BetaWorks. BetaWorks is a venture company, startup studio that stands behind Giphy, Medium, Kickstarter, and Bitly. And this is a synthetic camp that actually, that's why I'm here and the rest of the team is in New York. And this is a 12-month or 11 or 12-week long camp that is focused on bringing synthetic media into the attention of startup industry, but also media and entertainment. That also comes with a pre-seed investment, and this is pretty much the current status of the project. So we're going to raise in the next 3 to 6 months, and we're going to move this towards basically being able to generate much more interesting content on social media and so on. All right, so I'm a little bit ahead of time. I have a few minutes for questions. This is the comic I generated a couple of minutes ago from the InfoShare 2018. So hopefully this year, if you guys appear in it, you're going to end up in the comic book as well. And I'm open for questions. If you have any questions related to technology or, here we go.
First of all, thank you. It's very interesting work. I have two questions.
Mm-hmm.
The first one is, are you also filling the bubbles? And if yes, more or less how? And the second is, I think, more difficult question, because you told that most of the people use it to generate memories and so on. So does it mean if I want to use Comixify, you will see my data and be able to analyze it and how you will store it and so on, okay?
Yeah, sure. So first question, we don't fill the bubbles with the text from the video right now. We're looking into using basically subtitles and audio speech to text for that. However, the problem itself, it's a very good question because the problem itself, it's not just a simple summary. And this is where AI hits the borders of what people are creative about. When you write a story, when you create comic strip, which is a sort of summary, but in the same time, it's kind of, it needs to encourage people to get into the story. You're not just summarizing this. It's not like, hey, this guy is hugging into a cup, and then he's drinking a coffee, and then he says, "Oh, I'm sick." That doesn't contribute. So what happens right now? This is a way for us to generate the data. Is we allow the users to fill in the random jokes, and this works pretty well for some cases because it's a very memeable output. Like people can just fill in random joke and then laugh at Trump and say ha ha ha, this is super funny, let's share it with friends. But the end of the game is to actually allow people to interact with the bubbles so they can input the text inside. And we can train what exactly is being input into those bubbles. And there are a few approaches here. A summarization. There is also we're looking into research projects related to narrative and how you actually build a story, how you build a suspense. We're getting into this kind of psychological analysis of how the storytelling is built. But this is an ongoing project, and that's why we need to raise funds to get there. The second question, what do we do with the data? Very good question. So typically, if you're a startup, you don't think about it at all. If you get a little bit more fame, then you start getting questions from typically lawyers about that. So then you're like, oh, shoot, we should do something about it. We should put a disclosure or something. So we did that. We put a disclosure. Just for the sake of cutting the discussion, we never stored the data because we had only 1 or 2 GPU instances, so we couldn't afford, terabytes of videos being stored on our disks. But the practical output of this is that we don't really care about your videos that much. What we care about is the final output and how satisfied you were with the comic being the output of our algorithm, because that's the end game that we're aiming for. Like we're aiming for getting the data on how how you're interacting with the tool and how AI helps you to be more creative about your content. Not necessarily whether you were in the US or Hungary or London before.
Thank you.
Yeah. Yeah, so this is the version that we offer right now. The one page is limited. Also, the videos are limited to 10 minutes, and the size is 100 megabytes. That's pretty much. I mean, it used to be, I think, 25. Now it's 100 or the other way around. But the reason why we're doing this is because we don't want to get flooded right now, and we also want to cut off some, premium options for the users that are actually heavy users that want to generate the whole book. So I have a book that I generated with Comixify one by one that I printed out. We went with a family to the seaside and so on. So you could go around that, and there's no problem with actually applying the same methodology into the segments of the video and then just putting this together. We're just, as a small startup, we need to prioritize well. So this is not our priority right now, but you can go around that pretty easily. Yeah.
Okay. So maybe.
Yes, we did that, and this is actually. Oh yeah, I can show you that. That's the thing. Like this is a very good question, a very good comment, and actually people are doing this online. So if you go to Comixify right now, and then you look at popular, one of them is actually Game of Thrones. So.
Don't show the last episode yet.
Yeah, but there's a good one actually here. So now you can actually, vote for those comic strips, and this one is pretty cool. It's an Ellen show, and you can check it out yourself. But it's like, the beauty of this is that people are super creative. So now with the tool, we don't really need to be content creators anymore. We just allow them to basically do crazy stuff with Game of Thrones or whatever else they want. Any other questions? Yeah,
I have two questions.
sure.
About reinforcement learning. How
Mhm.
did you handle with the writing your own reward function? Because it's often quite challenging. And about the chart that you show us, the reward function, you could also, maybe that's the question is, did you thought about using some moving simple averages and like cutting them to choose the moments when the moving averages are cutting and choose by that the best frames?
So the first question is about reinforcement learning. The reward function, this is actually not our idea on how the reward function looks like. There is a summarization reinforcement learning paper that we cite in the paper, and this is the idea behind that. But for you to get a little bit of a feeling of what it is, if you take the frames and you move them into the feature space of ResNet features, what you're looking at is how the features cluster around groups of frames and how similar they are to the center of the cluster. This is the representative part of the reward function. And then there's diversity. So in other words, think about moving the images to some other space and then doing k-means. If you're familiar with the clustering algorithm, this is kind of a thing that we're doing. And this is unsupervised. You don't need to make up a lot of things. And this works pretty well. And the second question is about moving average. There are certain ways of finding the segments of the videos. Like we did the simplest thing that was, I think, cutting the scenes based on the difference in the intensities and how when you have the short scenes that are cut one next to the other, then you can easily detect the temporal segments of the video. And this is what we did. But to be honest, like since this is quite a bit of a complex problem of like setting first the frames, then analyzing them, then selecting them, then evaluating them, it doesn't really matter that much. And it's quite difficult to basically evaluate that on top of just subjective user estimate. And since we got hundreds of thousands of people using that, it seems that this works fairly well for the start being. But it's a good comment. I think we should explore that more. Thank you.
Okay, thank you very much.